Okay, we are new circuit. Okay, so we are spinning the segment. Okay, so this is still working. Let me share so that you guys see something. Present. So window. This you're going to have to talk if you want to interrupt, because I'm not checking. Like I'm sharing the whole window. Okay, so you need to talk if you have a question. All right, Arduino. Okay, so let's do this quicker. Okay, because it's a big one. This one's is bigger. Okay, Arduino. You guys see my screen? Okay. 7 seconds. Okay, so you guys are building that as I go, right? Like that's the point, right? Pot will go here. How about we rotate it right away? How about we do it this way? How about we don't? How about we put it this way? Okay, so we'll go. So the wiper, right? That's the signal coming out of the pot. Okay, so how about we go A0, whatever. And then what you do a voltage divider. So the one side, you go ground. The other side, you go 5 volts. Got that? Okay, I'm going faster here, so make sure you pay attention. 7 segment. 7 segment. All right. And let the fun begin. Okay. Since we're not displaying numbers, we're just displaying a bar. How about we actually rotate it to make it a bit easier to wire, right? It makes no difference for us, right? Because our pins are here, right? And so we'll go digital, right? So does that make sense? Pot, analog in, right? Because it reads a value that changes in voltage, right? That's analog. Digital, so it's 1 or 0, right? So that's why it's on or off. So that's why it's going on digital. Easy enough? Okay. Something that gets that even myself, okay, like when I started teaching this, like I was even myself a bit confused on how to use the 7 segment, because it had been many years. We need to pick the right one, common anode or cathode. Now, by memory, we're going to use common cathode. Let's just double check. Notice that I keep checking, right, online for stuff, right? And that should be the same for you, okay? It's just a good habit to not do mistakes that are silly. Okay, so I just want to confirm. I'm almost 100% sure that it's okay. I just want to confirm. Common cathode. So this one. Come on, computer. Okay, so you see what happens, right? So it's called the 7 segment, right? Because there are, right? If you count A, B, C, D, E, F, G, right? So that's 7, but there's an 8th one, which is an LED. So that's why it goes to, oh, in this case, yeah, so in this case here, they're missing the decimal point here, okay? So common cathode, so this is our drawing, right? So we'll send this to the ground, okay? Got that? We'll send that to the ground. Now we need to find our common, so that's the middle pin. Now these 2 pins here are shorted inside, right? So if you were to measure the resistance between the common at the bottom and the common at the top, it's the same value. Does that make sense? Sorry, it's a short, meaning they're connected. So it doesn't matter which one we pick. Now, some of you might think, well, we'll just connect common to ground. We could make it work that way, but it's not the way to make it work. What we need, remember, LEDs, you need a resistor to limit the current, right? So we'll use a resistor. We'll put we'll put 0.25, right? So 250 ohms, okay? and then we'll wire that to the common. Okay, so it doesn't matter. Is that big enough? You guys can see me? You need to talk because I'm trying to go fast. Can someone just give me a couple of thumbs up or...
Yeah.
Okay, we're good? Okay. Right. Okay, so you see this here, right? So we got A, B, C, D, E, F, right? So you see that? So how about we just follow the same logic, right? Since the letters are there. So we'll go letter A. I think it's this one. Nope, that's G. So A is here. You see that? So it's the top right, right? So we'll just follow the numbers, right? So we'll go A, right? So I'm going in a big circle so they don't cut, right? So we'll go A0, right? That's 0. We'll go B. Well, I don't really need to go around here, but you get the idea. We'll go 1, right? So the second one. C is here, right? So to 2, that's my third. You don't hit common. You go D, that's 4. E, that's 4. It's your fifth, right? What's that? E. Oh, come on. E, F. Oh, F is here, right? So make sure you get that right. So F is here. I'll have to go around. I'm going to have to cross here. All right, it doesn't matter. G, I'll go straight to 6. Okay, so just confirm you got them right. So your A goes to 0, your first. B to 1. C to 2. Right, my D to 3. Now, could you have inverted those pins? Go backwards? Of course you could, right? It makes no difference. But why make it complex when it's just going to mess you up, right? Your mind, right? When you build your code. So the point is to make it simpler on you, right? And this is just good practice. Any code, any programmer, that's how they work, right? So if they need to work with an output, a port, right? They don't start messing up the sequence just because, right? That's silly. There's no point. You could though, right? Nothing stops you of going nuts, basically. Okay. So we got the pot. I'm just, okay, notice, right? I always go back, I look over, just running over my whole thing. Is that making sense? Is that working? Right? So my value for my resistor, 250 ohms. Well, no, that's not what I meant. Just hit this, common cathode. We should be good to go. That looks good to me. Good to go? Okay, code. All right. Am I still recording? Recording. Perfect. Nope, this way. Okay, pin mode. So we need to copy that 7 times. We need to declare all of those as being outs, right? So you need that 6 more times. So copy, paste, copy. Okay, you need 7. 3, 6, one more. Okay, and then you go 0, out, 1, 2, 3, 4, 5, 6. Just confirm. That looks like that's good. Got that? Okay. We need, we'll put an enter here for our variables. All right. So we need to read from the pot. So digital, no, analog. What am I saying? Analog read, so capital R, bracket, what's my pin? A0, right? Semicolon, got the beginning, and now we need to read a value from this. So this is going to be an integer. Let's call it pot, right? Let's define it. As I said, it's always good practice. So 0, And then here, whatever we read from the pot, we'll say that's equal to that. Good to go, right? Okay, so we're defining a variable pot, potentiometer, and then we're reading it on pin A0. All right. Okay, so let's just review one quick thing. That's going to be quite essential for us. Analog read, Arduino. Our range was what? Do you remember? So it was 1024 divided in 4 or 2. I forget. So that's what we need to figure out. Oh no, that was the PWM. I'm getting confused with the PWM. Okay, so our range is 1023, right? So there's 1024 of them, but it stops at 1023 because we start at 0, right? Always 1 minus. Okay, so it's 1023. Okay, why is that important? Can someone talk to me? Why? Like, let's just put a comment here to not forget. 1023 is our range of values. Right, because essentially this is what I'll use here, right? Like whatever math I'll do, right? It will impact my like essentially. Sorry. So essentially, whatever I want to do with my pot, like I need first to know what I'm getting at A0, essentially, right? So we're going to have to massage that value coming in at A0, because 1023 is not a value that's necessarily useful for me as is. Does that make sense? Right? And essentially, most machines around us, man, it's got to be 99.9999% of all of them, of all the sensors in our machines, they're all calibrated. So what that means is we always change the values to mean something else once it's read, if that makes sense. Okay. Okay, I'm just thinking. Okay. Oh, this is a great opportunity here to learn about a NIF here. Okay, so we'll do actually a for, sorry. We'll do a nice for loop here, actually. Yeah. Okay, so we need a for. So it will be some kind of bracket that way. And then it will be, sorry, I need to get my English keyboard because it's just easier to get the opening curly and closing. Okay. Okay. Okay, so let's go back here. For C syntax. Okay, this is going to be important just to know our the specifics, right? Okay, so this is what I need. Let's look at an example. Okay, so this one here was good. But anyway, let's use this one here. Okay, so the structure is this. Okay, we'll just bring it to our code, right? Put a comment, so // right? Okay, let's make this wider. Right? Actually, I don't need this to be much bigger. Okay, anyway, that's good. Okay, so let me make my screen a bit bigger here for the code. Okay, big enough, right? All right. Okay, so I need an initialization statement. Okay, so what we'll do is we'll declare a local variable, it's called. We'll say integer let's call it segment equals 0. And then notice, right, I need a semicolon here, right? So I'll go semicolon. So essentially, you can do that, okay? So I don't know, every programming languages out there, obviously, but I'm assuming that that's a pretty standard feature of modern languages. Obviously, in old Pascal and all those things, it's probably not possible. Again, I don't know, but you can define local variables. So this here, actually, you could call it x. Actually, let's call it x, okay? And what happens is once the code exits the for, that variable x doesn't exist anymore, right? In the mind of the code, it's just for within that loop. So that's a very useful feature. Keep that in mind, but again, with experience, right? Okay, so what are we going to test? So we're going to exit that loop, right? Because right now I want to cycle through my segments, right? So we'll go 0, 1, 2, 3, 4, 5, 6, and then back to 0. 0, 1, 2, 3, 4, 5, 6, right? So to loop here, right? So we'll exit when it's greater. I have to go back and forth between, because I don't know where the other one is. When x is greater than 6, okay, we're going to exit, right? That's what it means here, test expression. And update statement, that means what do we do every time we do the loop, right? We that we do it once, okay? So here there's so those of you that are new to coding, there's this very cool feature about C, but again, I'm assuming most languages have it. That's the language I know the most, apart from assembler. We're going to do plus plus, okay? And that's what we call an increment. Now you could have it after, before, instead of after, right? But essentially what that means is once we've checked the value of x here in the test here, we're going to increment it by 1, okay? So because I could have said instead x equals x plus 1, right? But do you see how clumsy that is, right? Like it's so much more, right? So coders, because they do a ton of loops like that, they built it into the compiler to tell the compiler just take x and increment it by 1, because it's a super common feature of all coding, okay? Got that? So that's called an increment. So now what this loop should do, when it enters it, it defines a variable called x. It initializes it at 0. When it will have been checked, it will increment it by 1. And to exit, it has to be higher than 6, because I start at 0, right? So when we'll be on the last one, 6, once it comes back at the top, now x is 7, and it will exit. So basically here, it just checks for truth of that evaluation here. Okay. Comments, question on my for at the top here? Any comments, question? Interrupt me, guys. Okay. All right. So every time we'll be because earlier when I got quiet a bit just before I started this, I was wondering in my head, do I put that reading outside of my loop? But then what would happen is if I change my value before it does a full cycle, it will keep the same speed, and then it's only when it goes back to A that it will change the speed. And I don't want that, right? Because that's not going to be pretty. So that's why I put it inside my for. So essentially, before it changes the, actually we could put that at the end of that loop here. Okay, so that's why I'm putting a bunch of enters. Okay, so it could read it at the end, and then so we'll have a delay here. You'll see. I have have an idea here. Okay. Digital write. So now what we'll do is we will write at the pin 0 first, high, right? And now we need a delay. I'm wondering, delay, I'm just confirming, it's very likely just delay bracket in Arduino. Just want to confirm. Yeah, delay and then semicolon, right? And then 1000 is a second, right? So those are milliseconds. Okay. Okay, so our delay is pot. Should have called that. No, I can't call it delay because that's a reserved. Okay, so we're going to okay, so you see right here, that's where we need to do something to our reading here. So 1023 is our full range. So we're going to have to multiply this. So you can literally, so multiply is star, right? And we're going to put a factor at the front. So when it's at the max, it'll be 1,000 times, so it'll be 1,000. So how about we go times 5? So when I'm at max, so that'll be 5,000. So that'll be a 5 second. That's too high. So 1. Okay, you know what? You know what? We actually don't need to multiply it here, because that'll give 1 second. Okay, okay, that works. What's missing to my code here? I'm trying to make you guys think. Is this going to work if I just we're missing something, okay? But I'm trying to ask you, what are we missing? What are we missing? Anyone can guess? So we get in the loop, we write the first segment, so we'll start on A, right? We'll put it high, that's your hint. We're reading the value of the pot, we're delaying, and then what's missing now? Don't we need to erase this segment, right? So copy this, and then paste it here. Don't we need to erase it? So we need to put it low, because otherwise, oh come on, because otherwise what will happen is once it starts, it will just draw all the segments at the beginning, but then it will just we won't see the segments getting drawn because they're just fully on. So turning on something on, like, it won't show up basically. So we need to turn it off, and then it will go back at the top. So that should work as is. Let's give that a shot. So now it should spin like nuts. Wow, computer. So why can't we see it? It's probably because it's too low. Can't see it. So what are we doing wrong? Let's maybe make it a bit lower. 150. I'm going to ground. And I have a common What's my comment? Okay, let's just invert it. I don't see why that would work, but it shouldn't. Okay, what's going on? Okay, so I'm going to pause my recording. All right, I spent about 20 minutes here. There's a bug in Tinkercad. That's the only thing I can think of here. So I'm recording. This is good, right? Yeah. So the for loop here doesn't work for some reason, and I can't find what's wrong. So I broke it down. I just did brute force, which I asked my students to never do. And all of a sudden now it's okay, basically. So I'm doing it manually, right? So I'm doing digital write, right? So let's maybe get this a bit bigger, right? So I write the right segment. I start on 0. I read my pot. I delay by that value, and then I erase it. I increase my value of segment, and then I write the next one, right? So it's just the same repeat 6 times. And then at the end of that, I just reset it at 0. And since it's a loop, right? It's just going to loop forever. So it's basically a for. Highly unimpressed. Highly unimpressed. So let me show you. That works. So it spins, right? And then I can control the speed of that. Right? Okay. Yeah. Just silly. I can prove it to you if that's of importance. If I comment all of this out and I bring back my for, it does literally the same. Segment start at 0. It's defined here. When it's higher than 6, exit, and increment segment every time. And that will just do nothing. It's just dark. Nothing happens on my display. There's some bug. I'm highly unsure what's the issue. And to add to that, if I stop my when I have my serial begin on, that's just to log some data from it, to debug. And then it freezes. It does this thing. No idea. Just, you discover bugs every so often. That one I have no idea what's going on. So, right? So I'm gonna leave it like that. Comment this part out. Take that out. And then all of a sudden it works. Right, that's the serial begin now. That's acting up. So we need to get rid of that. That's really strange. Right, so it works fine. And you can control that. So super fast, super slow. Okay. Okay, so since this is really simple here, what I'll ask you guys now to do, I am not going to give it away, okay? to do this, to just copy this, will give you a 2, okay, out of 4, because that's too simple here. It's just too simple, okay. If you want to get a 4, what I want is when you're, sorry, I need to have it running. So to get a full 4, what I want is when you're in the middle of the pot, it doesn't rotate anymore. And when you'll be on the left side, this will make it faster and faster and faster, but spinning counterclockwise, right? So spinning counterclockwise, right? And then when it's the other side, now I want it to go clockwise. And so from the mid, and this is super fast, okay? So that's not an easy challenge, okay? That will give you a 4, okay? So I'll give you a few days to do that, at least one more day, okay? All right, so check on the Google class, okay, for more info. All right, end the block.